That's the concentration of the vitamin C lab. It's still gonna bring us here to this lab. In fact, we're doing 2 labs in one here. If you know what is titration and you understand that properly, then to do that lab, you have no problems. All right, they have no problems there, guys. So let us focus on understanding what titration is and at least have an idea of how we can carry it out. All right. So again, if you know, all right, let me put it this way now. You have you want to test one solution against the other, right? So that's the idea with titration. You have one substance, one liquid versus another liquid. You know everything about one liquid and don't know anything about the other liquid. All right. So the purpose of the titration here, what happens is that in this titration now, because you want to know everything about one liquid so that you can use that to find out something about the other liquid, it's important to measure the volume of that liquid. All right. In addition to that, you would need to know, well, let's say concentration then of the liquid, because when you measure it, in fact, when you know 2 things, and let me just emphasize this here. When you're dealing with acids and bases, 9 out of 10 times, you guys would be required to know the concentration of that substance you're using. So it's not just enough to say, all right, a base is a proton acceptor and an acid is a proton donor. All right, you know the definitions, fine. Maybe a 1 mark if they ask a question. However, what is more important is that can you tell the examiner the strength of an acid or a base? All right, there are 2 ways to do it. One is that you can use this measurement approach here. When you measure the volume of it, all right, let me just, this is interesting. This is not, it's actually not writing. All right, so that's not writing either. So I'm gonna have to reload this in. All right, let me just go back here and that's vitamin C. All right, and hopefully it loads here. It's not loading. So program, I have to close everything. All right, let's check here. The person's still coming in. All right, just a sec. All right, run it again. And going back to this. Somewhere here, so left here. All right. All right, let's go again. Yeah, there you go. It's good. Live. All right, so I'm gonna zoom in here. Go to this blank sheet and we go again. All right, good. So, all right, guys. So here we are. So as we say now, guys, when we're talking about acids and base, 9 out of 10 times, we're gonna ask you about this term. All right, it's gonna learn something called mole, something called, and as a matter of fact, no, let's put it here. It's actually, this is the right way to write it. So, and we have our volume there. All right, and the volume is measured in dm cube or liter. So I think when I asked a question, what about the liquid we measure in the beard, and it was Deborah who answered liters, but yeah, liters is the same thing as dm cube. So liter is exactly the same as this. Actually, it's a decimeter. All right, decimeter cube, or dm cube is the common unit. All right, so After we do this, now we're gonna look at some past questions and show you how those structure, because they're not pretty, guys. The past questions and titration, they're not pretty questions. So we have to pay close attention to this, and we have to go through this lab and understand it, at least partially. All right. If you don't understand everything, just know the definitions. Keep reinforcing the definitions like a memory gem, like one of them songs that we are singing, and it will stick in your brain there. But this is our formula for concentration. All right, and of course the unit. I'm putting the units. I'm putting what it is measured in brackets, guys. So that's what the brackets are for. So this is moles per dm cube, and I believe I've given you this last class, but I want to I want to give you this information so much that you remember it, so we have to reinforce it. All right, so any questions here, guys, at this point? All right, what is it that what is it that all right, so what is it we have here is our how to calculate formula, how to calculate concentration. This is needed for the lab, and in fact this is needed for like 3 labs in chemistry, crucial labs. As you say, these are exam passing information here. So how to calculate concentration? Firstly, all right, so basically this now, guys, how we use this triangle, it means that if 2 things are beside each other, it means that we multiply. If one is above the other, it means that we're going to divide. That's how we use this triangle. So for example, if I were to cover, and let me just show you this here. If we were to cover the volume here, all right, it means that in anything that they ask you for in a question, that is what you're going to cover. Everybody get that?
Yes, sir.
All right. So after writing the formula correctly, you are asked for something in that formula. You cover that part, and anything you cover now, you're going to use what is not covered to find it out, which is that moles is above volume and the division sign is above here. So it's like moles above concentration. In other words, if you know the moles and you divide it by the concentration, then you will find the volume. All right, that's what it means, right? And if they give you concentration in a question, or rather they ask you to find the concentration, then you would need to know the moles, and then you divide that by the volume. Hope everybody's getting this. All right.
Yes.
All right, let me show you then. It would be nice for you to see a question, because these questions, I can't really get them out of my head because I've seen them so often, and then I'm saying to myself, well, CXC really loves this topic though, so let's at least allow the students to try and love it too. So let's see if we can find the at least past papers. I have maybe some here that we can use while learning this formula. All right, and I just wanted to see how them just throw in the questions in especially in those question ones where that's the longest question on the paper. Even look, this is a 2008 paper. Let's zoom in and see what happens here. Just randomly, the first question we see on the paper is look at that, titration. Everybody seen that? This is
Yes, sir.
exactly what I'm talking about here. I didn't have to scroll far before I find a titration question, and then this was from 2008. It says when a strong acid is titrated with a strong base, the pH, change in pH. I mean, these are some terms that you want to underline now that you're just learning this thing. But when a strong acid is titrated with a strong base, a change in pH occurs, which can be determined, used to determine the end point of a titration. Now, this is a term, I believe it's on the lab sheet as well. All right, so this is a term, very, very important term, guys. End point of the titration. So titration is one thing, you know what it is, slow addition of acid to base, or maybe slow addition to base to acid, depending on what you're doing. But the end, there's an end point to that titration. There's a point where you stop adding. All right, guys, and this is real life stuff here, right? You guys might like to do certain things, and you keep doing it until, well, you hear a voice say, don't do it anymore. Right? Maybe you guys can relate to those stuff, but in this case here, there's an end point to a titration. All right, so pH will change sharply at 7. We're going to talk some more about the pH, but this question use titration, and they mention a lot about pH. Maybe you're going to ask you something about pH, and if you look here, they do ask about what the pH scale is. All right. pH meter can be used to measure changes in pH during the reaction. So there's a style of titration as well where we just drop the pH meter. And I'm sorry, I don't have a pH meter, a digital one somewhere in this room, but I forgot search the place. But hopefully you guys can see it though. So what basically I do is like almost like a pen like this, and then what you do is stick it in the solution when you're adding your base to an acid or vice versa. And it has a digital screen that tells you the pH when you're adding, so you can know when you need to stop the titration. All right. So in fact, there are some links on the the lab sheet as well. If you click those, you would see what a titration looks like for that. But look at this question. So the titration is common here. But look at this information here. We can't calculate anything yet, but just tell yourself, say, if them send titration, there will be a calculation. No, you can't get away from that. There will be a calculation for every titration. All right, in CXC. You can't run from it. So the best thing to do is to be prepared for that. And how when you prepare yourself? Well, when we see the question, a lot of words here. So CXC is saying, well, all right, a student who doing chemistry must can read. If you can't read or you don't read well, you're in problems here. As they would say, dog, give me supper. But you have to read through. You have to underline. If you're not reading everything, just underline the key things here. Looking at titration, changing pH, underline the end point of titration, because these are things that they could ask you what they mean. But let's see what they do so far. All right. So pH meter can be used to measure the changes in the pH and changes in pH during the reaction. Figure 1, and so they have a sort of well, it seems to be like a graph or a table, but all right. So figure 1 on page 3, and what typically they do here, this looks like table 1. All right. So and so get used to this as well, guys. With every titration, there's a table. Prepare yourself, guys, for every titration. There's a table. What does the table have in it? Why we need a table? To track the volume of base added, or volume of one thing that we add to another. Pretty much this. All right. So you see them start with 0 here, and they have 5, 10. So it goes up by whatever range. It doesn't have to be equal range either. They just put in some data here, and it goes. This is 0. They collect the volume at 5, then 10, then 13, and 14.5, 15, 15.5, 17.0, 20, and 30. All right. So notice that there's no uniform thing. It's not like they go up by 5 each time. Them just go up by whatever number them feel like. So that is what I would call a curveball in CXC, because, well, there's no pattern here, and students might be saying, but our teacher gave us in order, so hold them, but then that's just style, guys. That's just a style. Them mess with your head, but be strong here, guys. It's a table just like any other table. So any questions so far, guys? No understanding what's happening?
Yes, sir.
All right, make sure. All right. So then so we have the pH reading here. All right. So for every volume of base that is added to the acid, in that case, there is a reading, pH reading. Now, this is where the term endpoint comes in. And an endpoint is saying, well, all right, you add X amount of, you add up to 30 centimeter cube. Now, we said that decimeter cube is the official unit for volume. However, let me show you this. CXC will give it to you in centimeters cube most of the time. 9 out of 10 times it's going to be centimeters cubed. So what you're going to do here is when you get it in cm cube, you actually divide this by 1,000. All right, to get it in dm cube. All right, so I'm just putting that at the side so you know. Say, well, all right, all of this when we get here, if we go convert it to dm cube, may be required. You might get away with it because if you get the volume in well, yeah, you're definitely going to have to convert. There's no way, you can't run from it. So get used to that, guys. So that's another trick up CXC sleeve, something that you need to arm yourself with before exam. If it's a titration question, the results are in cm cube. Just tell yourself that this have to go convert to dm cube. And what you're going to do is right away divide each of these by 1,000. Of course, 0 by 1,000 is still going to be 0. But then 5 divided by 1,000. So what I would do here in exam situation is be prepared. And see access to these things, them say, well, the students are well prepared. So it does help your class in the exam. They would more likely want to pass, especially if you find yourself, let us say you fall short on other questions. They will look at your paper, and because what they do know, them look at all the scores and them get just the raw scores out of 100, and they decide where the grade 3 going to drop. So they have the software plot it on a curve, and them just when the curve plot, them just draw a line in the middle. And sometimes that happens to students. Some of them score fall on the other side of the line. Now, when them draw the curve, the examiners draw the curve. So them say the bell curve them use. Some students might be close to the middle, and those are students whose papers they will pull at random and remark. No, if them pull your paper and say you took a disciplined approach to the exam, that meaning that you did all right, so fine, you didn't do so well overall, but the way which you did the questions you did, they will pull it and say, well, the student could be upgraded. There are some arguments for some students getting better grades than they deserve because of that. It's the way how they did the exams. They can see when a student just had a bad exam, different from a student who wasn't prepared or don't know anything. So you want to put yourself, because a lot of you have been coming to class regularly. So some more regular than some, but the point is that your reward in exam is that if you're afraid of exam, you have to have a disciplined approach to the paper. You have to tell yourself, say, this is how you're going to approach the exam. So it really reduce the lack of confidence. Because sir already tell you said the first question I go carry 25 marks, and it's a paper, it's going to be most like a lab. So you apply what you're learning now. So in this case, you do some simple things like this, make your exam easier by converting stuff. So the centimeter cube, guys, as we say, that should be converted to dm cube by dividing it by 1,000. So when I take 5 and divide it by 1,000, anybody know what number I'm going to get? All right, this is something that you can
0.005.
All right, so that, and then you're going to have 0.013 here. So these are little things where little tactics you'd use here. 0.145, but these 0.015. So these are the small numbers you usually get to work with in titration. So don't be afraid of it. It's part of the game. Not gonna be nice, large, round numbers you're familiar with. A lot of these numbers are decimal points. So 0.0155 would be the number there. And of course, we have 0.17 here. And of course, this would be 0.02, and then 0.03. So that would be your answer in dm cube. All right, everybody understand what we did here?
Yes, sir.
All right.
Yes, sir.
Very good. So simple conversion from cm cube to dm cube. Need that for the lab, need that for exam. All right. Now, the next thing is endpoint. We have focus there. The titration now, guys. If it's an acid versus a base, we are going back to the question to get some clues here. And that's why CXC and in a lot of words, very wordy questions they try to use to play with your brain. Look at that. Explain what is meant by each of the following endpoint of acid base. So you see it's right there. It's right there, guys. So these questions are predictable. If they're gonna send titration, you must get something for calculate. But let's go back to the question to find something else. It did say a strong base, guys. So there's another clue there. Strong base. All right, this now, the strong base is telling you, it's giving an idea of the pH that you start with. So a strong base will have a pH, usually 13 to 14. So let's go back to the data and see what happens here. So now we are seeing it starts at 2 here. Starts at 2 here, and there's a reason for that, because let's go back to the question. Strong base though has a pH of, say, let's call it 12 to 14. All right, so let's put that in perspective. I want you to understand this though, that pH of 12 to 14 is what a strong base will give you. All right, now it's an acid-base titration. Let's find the acid here. Strong acid is right here. Strong acid, pH of a strong acid will be between, we'll say that, could be, let's say 1 to 2. Yeah, 1 to 2. So what we're seeing here now is something that had a pH of 1 to 2 going against a substance that had a pH of, say, 12 to 14. All right. Now, remember that the pH scale goes from which numbers? All right.
0 to 14.
Yeah, very good. 0 to 14. What happens in the middle?
It's neutral.
Very good. That's all I need to know, you know. That's simple stuff. The 7 is neutral. So that's where the endpoint is, you know, guys. Although when you look at the definition for endpoint, we have to take some other things into consideration. But with the when you're using the pH scale, the pH will change sharply at 7 at the endpoint. You see that now? So endpoint have something to do with the change in pH. So this information, guys, what I'm giving you could potentially answer these two questions, which I can tell you they are coming back on some exam paper. Could be your own, or could be the one after that. You know, who knows? But it is very likely to be asked again. It's still on the syllabus. So yes, go ahead.
I see that you gave us the number line a while up. Not hearing about number line. It's not number line.
Yeah, it is a number line in a sense, but go ahead.
The scale a while ago.
Mm-hmm.
It is a number line.
Yeah, it is. Yeah.
Ranging from 0 to 14.
Right.
Okay, so.
Mm-hmm. With 7 being, you know, in between, so neither acid or base. So, and that's one thing I left off the line, that you know, over here, so if I could just change the color here, that's a red here. So, and of course here would be red, would normally represent acid. So if we had blue litmus paper and it turned red, it's acid. And of course for the base is blue, because, well, let's just say if you had a red litmus paper and you test the base with it, you'll get a blue color change here. So I put base there instead of okay, let me just put the base there. All right, so there you go, acid and base. So on one side, less than 7 is acid, and then greater than 7 is base. Hope everybody get that. And that's the pH scale. All right, remember the scale just tells you the scale just tells you how a substance responds to hydrogen ions, you know. So if it have a low potential, plus P stands for potential and A stands for hydrogen. So if the substance has a low potential for hydrogen, meaning that it's at, say, 0 or 1, let's say it's 1, then what it means is that the substance really doesn't want any hydrogen. It doesn't have any potential for it because it has a lot already.
Sir?
Yes, go ahead, Leandro.
Could you repeat that again? When you said the line represent how a substance react to what?
To hydrogen ions.
Okay, thank you.
Yeah. All right. So yeah, once hydrogen ions are present in the solution, the pH scale can tell you how it stays. So whether it's water, salt, anything you can think of in liquid form. All right. Important thing, it has to be in liquid form. Anything in liquid, even your blood, it can test to see how much hydrogen ions are available, or how would this substance respond to hydrogen ions. All right, that's basically what the pH scale, the potential of hydrogen. All right, so hope you get an understanding of what this is. Very important stuff, guys. So, all right, do you guys have any questions there?
No, sir.
All right. So yeah. So well, all right, fine. So now that we know what is acid ranging, anything less than 7, so that's from 0 to 6.9. And then of course a base would start from 7.1 to 14. The strong acid is being specific now. Strong acid would be over here. In fact, the acid line now can even split into saying, well, strong and weak. So we could have strong over here, all right, and then over here, so now it would be weak. All right, so weak acid. All right, so that's where it is. All right, no, and then of course on the base side now you can have a strong base and a weak base. I'm sorry, strong base would be more towards the right. So let me just put that over here. Strong is over here, and then of course over here, so it's weak. So we're seeing that it's like the opposite then, in the sense of the right and left here. So so weak base and of course strong base. So a strong base would have there right there, weak base would have be closer to the 7 mark there. So that's a line. Yes, go ahead.
So the wheat base would range from 7.1 to 9.
Yeah, about that. Yeah.
Okay.
Yeah. And then like when you reach like 10 now, it's sort of in between. It's neither strong or weak, so it's just ideal. But when you do more chemistry, you know, in real life now, you see this talks to you in terms of substances. So for example, I'm telling you like a little theory now, but in real life, if I'm talking about a strong acid, I'm thinking of like hydrochloric acid or sulfuric acid or nitric acid. Any one of those three are strong acids. So if I need a strong acid to do something, it will be one of those. So in this question, they didn't specify which one, or did they? We would have to read and see if they did. And they actually did. If we read further on, we see that them say sulfuric acid was used. So that's a strong acid. In fact, let me just change the color, put it more in the black there. All right. So let's look at it. Figure 1 shows it the 10 pH readings when a student uses the pH changes to determine the endpoint of an acid-base titration. So yeah, you can definitely see, guys, that they expect students to have done this lab or not have it. So, and if I scroll this paper, we're gonna see more and more questions close to this one. So let me go back to this titration paper because I think there's some information in it. And in fact, okay, in fact, I did say explain what is meant by endpoint and so on in there. I wonder if I gave it to you in the theory as well. All right, no. So I told you what it is here, and so, okay, no, let's say endpoint is right here. All right, hopefully you can see this, guys. All right. When enough acid has been added to neutralize the alkali, which is a base. Alkali is another word for base. I'll tell you the difference later on. But when enough acid has been added to the base, the indicator, that's underlined here, changes from pink to colorless. This is the end point of the titration. So usually now for end point now is that point where there is a sharp color change in an indicator. All right, that is basically the indicator is placed in the substance that is below the top of the burette. All right, so this is in this example here, in this image that you're seeing here, we are seeing that, all right, there is a flask below the burette. All right, everybody seeing that?
Yes, sir.
Flask below the beard.
Yes,
All right. So now notice that is where you put your unknown concentration. That's the one where you know the least about. So in the case of if we're gonna apply this to the vitamin C, because we don't know anything about the vitamin C in whichever fruit we're going to test, whether it's pineapple or grape, that has to automatically go in the flask, right? It has to go in the flask because we don't know anything about it. What we will know about is the base, because to put the base in the beard, before we can put the base in the beard, we're going to have to measure it and we're going to have to go mix it out. All right. When we measure it and mix it out, we're recording those measurements because, well, we need to know the mass of the base. Usually the base is in solid form, by the way. And sorry, I don't have some base here. I usually have some base here. You use as drain cleaner. So when the sink clog up now, anybody know those liquid drain cleaner pellets them that you use? Throw in the sink. Whenever they clog up.
No, sir. I know about the liquid.
All right. Well, let's look at what that is. I'm gonna show you. All right. So well, you use a liquid, and that's typical Jamaicans. They try to go for the easy way out. I am clean. I want to know what is it that I'm getting. So, let's look at drain cleaner, and this will be like our sodium hydroxide. Typically, that's what we use. So, sodium hydroxide is a very good drain cleaner. In fact, nowadays I'm use all right, and this is actually a solution, but then what I wanted to know and is the other farm, the main farm it comes in. So if we're at a school lab, yeah, all right, this is what it looks like. So let me just bring the lab to you guys. Let's just show you what it looks like. New slide here, put in this here. All right, hopefully you're seeing this, guys. See this is sodium hydroxide pellets. All right, hopefully everybody's seeing this. That's what sodium hydroxide look like. All right. No, this thing is very slimy. One of the rules of bases is that bases are slimy. All right. Bases are slimy, bases are bitter. Okay, those are two characteristics of a base in real life. So just know that anything slimy or whole is most likely going to be a base. I know you guys might hold slimy things from time to time. All right, you in fact can probably bathe with a slimy thing. What is the name of the slimy rectangular thing that you bathe with?
Soap.
Soap.
Black soap.
Black soap. Hey, black soap.
No man, bathing soap.
Oh, black soap is the thing. Is you get a black soap? Because black soap is I want soap on the market now for pretty up your skin. All right,
Okay.
yeah, but soap definitely is an example of a base. Soap is actually made using this sodium hydroxide. So when you're doing the acid-base titration, this is the base we're going to use, and what we normally do is dissolve this in water. Yes, go ahead.
You said bases are normally slimy and what?
Slimy and bitter. Yeah, go ahead.
Okay.
Slimy and bitter. So and maybe in biology you come across that in reproductive system, because that's something that you would screw your face at first, but when you understand it, you understand why there's some sliminess there, because the base is there. So sperms of basic environment, and so on. So that's how nature is. All right. So yeah. All right, guys. So then that is what sodium hydroxide looks like. Going back to CXC stuff here, because it says here the end point of the titration. All right, watch this now. The acid used. So in this case now, them tell you everything about the acid. Then you see, for instance, this information. The acid used is 20.0 centimeter cube of 0.05 mole per dm cube sulfuric acid solution. I will just underline that, guys, when I'm reading the paper, and go ahead to work out the obvious thing they wanted to know. All right. 20 centimeter cube. What information is this? 20 centimeter. What is measured in centimeters cube? Or what did I say was measured in centimeters cube?
The volume.
Volume. Very good. So I'm going to write volume here. 20 centimeters cube is volume. All right. What did I say was measured in mole per dm cube?
Concentration.
Very good. So I have volume and concentration. So guess what, guys? I can calculate. I can get a mark. I'm sure of a mark here. And this is why I like CXC chemistry questions like this, because they are they can't stop certain marks from flowing if you're prepared for exam. Let me just go. All right. So I'm gonna go back now to that formula that I showed you. And as I say, understanding this will make you understand the lab more. Everybody remember this formula?
Yes, sir.
Yes,
all right.
sir.
So good. We're going to use this formula again. Obviously, you get the concentration, you get the volume. What can they ask you for? Only one thing they can ask you for.
Mole.
Moles. Exactly. So you're just going to cover that now and say, bam, that is what they're going to ask you for. You're going to get 1 mark for this, one mark easily. And what you're going to say is that moles, and this is what students would write it typically, moles is equal to concentration times volume. That's it, They're going next thing you're going to do. You know the formula. Let's go back to that question. In fact, I'm going to just copy that page in. Make life easier. I'll copy this page. And just minimize that and put it right here. Because you see, we are multitasking here. You're doing a CXC paper as well as learning to do a lab here simultaneously. Oh, what did I do wrong there? Let me just paste. Okay, so I'm gonna paste, keep the source formatting. There you go. All right, and then I'm gonna zoom out. All right, I zoom in. All right, so you see that we have the volume and the concentration. So volume is 20, concentration is 0.05. Look at those small numbers I was telling you about that they will give you here. Let's go back down in this question. Concentration, they said it's gonna be 0.005 if we remember clearly. So that's 0.05, all right, mole per dm cube. All right, and notice that the way they write it is different from how I write it, but it's the same thing. I would say moles per dm cube, the slash, all right, that means to divide. But then it's mole per dm cube, or as how they write it is mole dm cube to the -3. That's the same thing. So let's put r there. All right, but the important thing is that it's 0.05 is the number if you go back to it, and the volume now is 20.0. So if you remember those information from the previous paper, previous slide, it's 20.0 centimeter cube. Again, there's something wrong with the units for volume here. Something needs to happen to it. What needs to happen to it?
You need to convert it to dm.
Very good. Needs to convert to dm cube. So how we do that again?
Divide it by
1,000.
1,000.
All right, very good. So you guys are learning that, which is important and lovely. All right, so it's 20 divided by 1,000, which would give you what number?
(0.02).
All right, so it's 0.02. So 0.02. And then that's it, That's we're almost there. We're almost there. So we're just going to simple multiplication here. What I'd like to do first though is that I want to get the units correct. So you notice that this is in dm cube now. All right. So in fact, I'm going to draw a line through that. So I know this one is the one we're going to use. What's going to happen here? This going to cancel that. 2 units are the same, mole per dm cube. The answer will be in moles. Moles are measured in MOL. All right. We're almost there. We need to get the number now that should go beside that. So it's going to be what? 0.005 times 0.02. And that should give you a number in the magnitude of what? 0.0001. That's what you probably get.
No, sir, you get 0.001.
Okay, yeah, it's gonna be double. Yeah, double zero, right? Because yeah, 5 times 2 is 10. Yeah, that's true. Well done. All right. So this is the answer. All right. So this is required. Notice that I didn't see this question on the paper, no, you know. But what I know, say, once I see it there, it will be asked. No questions there. It will be asked. It, in fact, we want to go through it, hopefully. Maybe not tonight. We might not have enough time, but certainly you will see this question being asked. So when we're doing acid-base titration labs, these are some of the things that they want to see you carry out. These are some of the calculations they want to see you carry out in the labs. And that's what carry the weight in with the SBA, the type of labs that you do here. So crucial here. So that's it. All right. All right, we won't trouble the definitions right now, but whereas you're there, the base, so them tell you, say the base solution is sodium hydroxide of unknown concentration. Bam. All right, that's cool. Reading 1 represents this amount of sulfuric acid. Remember that the sulfuric acid is what we know everything about. We know even the moles of it that we have now. All right. Let's see what happens here. It says now reading 1 represents a pH of 20.0 cm cube of sulfuric acid at the start of the experiment. Where is reading 1? Let's see if we can find reading 1. It won't be on this page, certainly. Would be on the other slide. So let's go to it. Reading 1. Reading 1 looks like it's is this reading 1? I'm seeing the pH meter readings here. The reading 1 there is okay. So then basically say them started it's just the base with them add my base added. All right, no problem. They add the base there. In this looks like the base is in the burette. That's why I'm saying base volume of base added. You have to add this with the burette. The acid that we just find out has this pH. So what I'm basically saying here, guys, is that when there's 20 cm cube of acid, the pH is actually 2.0. In fact, in this question is sulfuric acid. So this again, I'll tell you this, the students need a lot of practice with this one. This, I would say it's a lot of information to store in your head going into an exam, but again, repetition is key here. So again, guys, just understand the question here. Them telling you that the acid use is 20 cm cube of this. So them telling you how much acid them start with. All right, how much acid them start with. The acid is 20. But what's happening in this experiment is that they are slowly adding the base to match up with this 20 cm cube of acid. So them they check it at 0, then they check it at 5, and this is the volume being added now. Remember that it's 20 in the acid. They start with 0 and take time add, measuring the pH change each time. This is a lovely experiment to really do because I've done this year after year and I love it. So you just slowly add it and you see that pH just in this case the pH is increasing because you're adding more base. I remember on that scale that I showed you that the base is the base has a higher pH than the acid. So when you're adding more base to this acid, the pH definitely going to increase. But something happens here. What CXC do know, them leave out some blank space now because they want you imagine what would be happening in between these numbers here. So when you add only, they don't give you what happened when you add 5 or 10 centimeter cube of base, but they give you what happens when you add 13 centimeter cube of the base to the acid. Remember, guys, it is 20 cm cube of acid. That is constant. That is constant. The volume of the acid don't change. Them just put that in the flask and leave it and put the pH meter pen in there and make it stay in there. And then you just add your base to it now. And You know, so if at time that we're low, I'll just show you a video of that another time. But that is what's happening here, guys. 2.8 when you add 13. And then when they reach 15.5 now, the pH, so then they reach 10.2. Something happened in between here. Endpoint is somewhere here. So we're going to have to find that. Endpoint is somewhere. I could just write this here. I can predict that the endpoint is somewhere there because the endpoint is where did they say anything about an indicator it used? They didn't say that. No, they didn't use an indicator. That the pH scale is actually the indicator. So that is it now. That is what we're looking for. We're looking for the point at which this pH here suddenly just sharply change. The endpoint is somewhere off here. One out of these two is the endpoint. Between 15, I think possibly between 15 and 15.5 there, the endpoint is somewhere there, guys. So we have to go predict. But well, you know, another thing they would want you to do with this now, guys, and a lot of you guys never see this in chemistry before, but you're gonna have to plot a graph. You're gonna have to plot a graph for this one. You're gonna definitely have to plot a graph here. But let them see something here when them ask you for 2 marks for this. When they giving you 2 marks for here. See there using the graph paper provided. And there's a graph. Didn't see the question, but there has to be a graph here. Plot a graph of pH against volume. See, this is a real lab question. Real lab question. So they're not playing with you guys. CXC is not afraid of you guys. They will throw it, they will drop it like it's hot on you guys. It's serious stuff here. All right, so plot a graph of pH. So, all right, I could go ahead and show you what this graph would look like. It's pretty much a predictable graph. Usually the acid-base titration graph, it's supposed to look like this. Let me see something. It's like pH versus volume, and then volume of whatever added. Normally the graph them would have said so. And then the endpoint would be here, whichever volume here. So the pH drop sharply when it reaches so probably about 7 would have there right there. So and that's the go. So let's start the acid with 2, and then you keep adding the base, so volume of base. So this is just me sketching what the graph would look like really. So this line here, so now would that be the endpoint. So somewhere off here, so will be the endpoint. And so this is acid base titration graph. All right, that's what it look like. All right. More on this though. This will take some time. In fact, we have to go find even one time outside of class time to really talk about this. You know, if we can find any other time to do this, just let me know if you guys can decide on a time. But this have to luck. Have to spend time on this. All right. Serious chemistry. I've been waiting to teach this topic a long time, but you guys wouldn't have enough knowledge at the time. But we have reached here, guys. We have to make up our minds. So this is like one of the peaks we have to climb on the way to exam. So yeah. Any questions here, guys?
No, sir.
Sir, can you send the notes in the group, please?
Notes in the group. All right. So notes in the group would be this and this the past paper question. All right. I'll take me the copy this. Let me just say sample. All right. All right, we'll run this now. All right, copy. All right. Put it on the actually this would be in the lab. On the lab sheet. So I'm going to do this now. Probably put it here, so yeah, and keep the formatting. All right. Yeah, quite some important stuff this evening, guys. So sodium hydroxide look like, and what I would want to do, guys, for assignment. And look at this. I even gave you another question as well in the same lab sheet. This was which year? 2014. So again, it's common. But more on this though. We have to go spend time on this though, guys. We can't make this one slide. We have to do this. Get it good. So what I want to go into here is just convert it to a PDF file and send it to you guys. And today's date would be what? April 26th. All right, so and a little bit of a log here, what 2021. All right, and let's save that one. All right, there you go. All right, and let me send this right away because if I might forget. All right, I'll go ahead. But you seen it?
Yes, sir.
All right, so there you go, guys. I'm gonna say this is a serious topic, guys. Chemistry gets serious now, guys. All right, chemistry gets serious now. So try and lock off titration. In order to lock it off, we say just know basic stuff, what an acid is, what a base is. All right, the terms used in titration, very, very important. And then it's something that a lot of persons later on in chemistry, you spend time in it, you get full of it. And if you're going to any form of science in college, like medicine or medtech or pharmacology, titration has to be, it's like a skill. It's like learning how to drive. That's what titration is to a chemist, learning how to drive. So you guys just try and get to love it and read up and watch videos and see how it do. You can even do some makeshift titration when I was about your age and even younger as well. I would have used syringe and do my titration them at home. Right. So I was a very idle child, so any chance we get very mischievous, find anything lying around, try and make something out of it. So that's how it works. So as we say, that helps you to remember things. So all right. So that's it, guys. If you don't have any more questions, then but then so not talk to me about the extra time now. Which other time outside of regular class time we can use? Saturday might not all the time. Is there any other time? Or can I just spontaneously say make we talk to you?
There,
Can I be spontaneous? Yes.
sir, it has to be probably like a Friday or a Saturday, sir, because the rest of the days, sir, I have classes.
Cool. All right. No, guys, if you have like study group and so that's it's a thing, serious thing now, guys. No is what? No is well, April don't know, guys. Me and no exam is in June. It's no or never, No or never.
Sir, anytime is fine with me. Any day.
All right.
Sir, any day except Saturday is fine with me.
Okay. So as I say, I'll just probably just send a message in the group then and then, allow you to meet with me and online and then we probably go through some past paper. All right.
So do you have the timetable to say when we will get the exam?
No, I don't have a timetable. I think it was sent in the group though.
I'm sorry, we can access our timetables online now.
Here you go. So it's online to Gabriel, as Leandra is saying.
You just
Sir,
need
so we don't, you're gonna plan to have any more face-to-face leading
Yeah.
up to
Yeah, man. That is a plan. That is definitely in the making. So we will meet for face to face before. Very likely, but the Saturdays them seem to be everybody's running to Saturday classes now. I think bio and math are having Saturday classes now. But regardless of that, I still will be trying to make myself available on Saturdays for the face-to-face classes. And I don't say if not face-to-face, we use up the online space as much as we can. I would say I really go ahead.
Sir, what about marathons or whatever?
Yeah, well, marathons can work, I have to say I am for those things, it's you guys need to show me say you don't want it. I shouldn't be the one saying let us have a marathon. Like say is me want pass the exam. I've gone through that long time. I want to know if I go there and I realize say what I wanna need it for pass it. As we say, Carly said no, it's me. That's only 1 month before exam is in June. It's no or never. No or never. We're closing off the labs now in the sense that all right, I would have wanted to do a certain number, but fine. We reach the minimum at the moment. No. We actually fine with 7-8 labs. So right now. So
So you're saying we're only going to do 8, or are you going to give us?
no, I'm not saying that we're only going to do 8. But this strategy I'm using now, where I'm actually giving you 2 labs and doing the content simultaneously. I could do that for the others. If you understand what I mean. So
yes, sir.
so I could do it like that for the others. You get a lab to write up, as well as cover the content. Because as we say, I use labs to teach. I don't use labs for SBA. I use labs to teach. And then when you learn from the labs now, then you write up your SBA, and then you get a better grade. Right? I could just say we just doing a titration and just bam, run through some up or something, get some results, write it down. And when I go to market now, the knowledge is not coming out in the writing up. I want to see the knowledge showing because you have a reflection to write. And I'm more interested in you guys learning the thing than
I have bio.
competing. Yeah, go ahead, man. Yeah. So I say you learning the thing than you guys just writing, doing the SBS. Doesn't make sense. So let me say, guys, just work with it still. We're not gonna reach the requirement after completing these 2 labs. And based on what we do today, you're supposed to can add some more to that that something, that fruit juice lab. Those who don't have class can stay a little longer. Can you guys stay a little longer?
Yes,
Yes.
sir.
All right. So those who have class can go. But I want to bring up this lab, that vitamin C lab here, because what we have done today could help you to add more things to it. Because even right now, all right, so we can get the variables out of the way. The variables now we'll just talk about is the same thing. You remember that triangle that I draw a while ago? This one, it's this triangle here. This one here.
Oh,
Yes,
yes.
sir.
These are the variables, These are the variables. So the variables then is that, all right, I'm gonna show you this now. Because the vitamin C, if I apply it to the lab, the vitamin C in the juices, those are unknown. So you see, because those are unknown now, these would be, well, let's see, let's go. Well, first of all, it's vitamin C is an acid, so all right, so that's the acid. But then plan and design, experiment to test the claim. All right, suggestion is to the hint is really to use a base to titrate against the unknown concentration of acid in fruit. All right. All right. So now this now should be a bit clearer to you now. So you have your juice now. What is it that you're going to do with the juice? All right. So your aim is then, because your hypothesis is going to say, by the way, you can choose one or come up with your own. You don't have to use pineapple grape juice, or you can just use fruits that you have available. So you're allowed to write one of your own hypothesis. But let us say you're using pineapple juice then, higher vitamin C content than orange juice and grape juice. What I mean is that the aim could be to determine the vitamin C content of well, let's say, in fact, you're going to have to use all three juices in this case. So of orange, grape, and which one is pineapple? Yeah, probably not spell pineapple properly. All right, and pineapple juice. So so this is your aim, you know, that could come out. In fact, all three of them, that's the trick here. all three of them can have the same aim. So I actually designed it this way so that it make it easier for you, so you don't have to struggle to find out. So what I mean now is that I remember I say one of them you'd have to go implement. For find out implementation. This is something that we can do at home. Or what I could have do, the students did this last year, a year before last, they did it. So I could go for those results and up at school and give them to you. And you write it up as the implementation. All right. Because this lab, it was a long lab, you know. I remember when I did this lab with the students, I had like everybody there. They were there from like 1 o'clock and we never finished till almost 8 o'clock. Because you know they had to be just to say it's a long lab. So 3 different juices, you have to get the juice and then when you get the juice now you have to filter it. So you need like a strainer or something. Get out some of the little pulp and them thing out of the fruit juice and just get the raw juice, and then now you have to add distilled water to it, and then you have to make sure say each of the juice them you measure and have the same volume. So the same volume of juice you have to use. So that is a variable. We're going to write the variable there as the that's going to be the control, by the way. All right, volume of fruit juice. All right, let me see something. Yeah, I just swear I'm losing my ability to spell. All right. Anyway, so any questions here, guys?
No, sir.
All right. All right, volume of fruit juice is used. I'm tempted to say amount of distilled water, but I won't stretch it right. I won't stretch it yet until I see it plain out. But definitely the volume of fruit juices used have to be the same. All right, what will be different now if you have the fruit juices? This is actually having this is the you won't treat this as an acid, by the way. So then it means that if you are going to find out the concentration of it, well, the manipulated variable, and let me just probably correct spelling of this word. The manipulated variable then would be what is it that you're adding to the acid. So what do we normally add to the acid in a titration? That's the question. What do we normally add to an acid in a titration? Anybody? What we normally add to acid in a titration? What we learn from today class? Students, what two substances are on the pH scale?
So what to mention?
Me ask you what mean. What two substances are we right on the pH scale? What go from 0 to 7 and what go from 7 to 14?
Acid.
Base and acid.
base.
Exactly. So a long time when I say that. So so we should have said base. From a right acid and it's a titration, it have to be base. It's only one way you can go. So all right. So the independent variable then, the manipulated one now is the one where you know is that is the thing that you're going to add. All right. So the independent variable then, let me even write it because I think I gave it this in the previous panel design. But independent variable is the variable that you are in charge of. That's the one now where you're that's the one that you're controlling, not you're the one that you're adjusting then. So we said that this, first of all, the control is the volume of the fruit juices we're going to use. Remember, guys, we cannot we have to use the same amount of pineapple juice, orange juice, and grape juice to see which one of those have the most vitamin C. Right? So we can use more pineapple juice than grape juice and say, well, all right, then the pineapple juice have more vitamin C. No, it have to be the same. All right. So they're coming like this then. It's like if you want to test like the fastest car, for example, right? You have to make sure say the car them have the same size, you know. You can't test like a truck then against a car, a van. No, it have to be the same car, if you understand what I mean. You have to put like with like. All right. The same thing now with competitions. Then put children in sports in the classes. If you understand what I mean. So the same thing with these fruit juices now. They have to be within the same class. One thing you can use to put them in the same class is the amount we use. All right. So that is the concept here, guys. All right. So that's why I would say the control variable. The control variable in this lab is a variable, or is that thing that you won't trouble none at all. So if you decide, so we're gonna use 20 cm cube of each juice, then 20 centimeter cube, 20 centimeter cube of juice, that's what we're gonna use for the entire thing. Now what would respond now? And then there's a good thing here. We're going to find out the manipulated variable now in this case is gonna be the what? When you add base to it. So addition of base to acid. All right. That's the one that we are going to adjust. So this is so the first variable control is fixed. We're not going to trouble that. In fact, we set it one time and left it. Everybody get that?
Yes,
Yes,
sir.
sir.
All right. So let's put an example. Let's say 20 centimeter cube. All right. Independent variable, we are adjusting something to see what will change as a result of what we did. So you know, women who like to keep them house clean and so now they like to shift and shift up the chair, change around things to see if it's a better experience being in the room, things like that. All right. You know, that's how life is. So we adjust to see what would be better or what would be worse. In this case, we are adjusting now the amount of base added to acid. All right, so that's the additional base to acid via titration, by the way, just to be specific. That is our manipulation. That's our adjustment. All right, so we adjust. All right, responding now. After you adjust that, now something will respond. Can anybody figure out what will respond when we add a base to acid? What are some of the things that will change about the acid? From today's class, you should tell me one thing, because the acid and bases are measured on a scale. What is the name of that scale?
The pH scale, sir.
Go ahead.
I think it will become neutral.
All right. So other way you just say you think it become neutral. It probably could. It really depends. We don't know if the acid is a strong acid or a weak acid either. So that's another thing. But it could become neutral, Titration, but then it may not. So what we're gonna do here is we're gonna say the responding variable, what will respond to addition to the base is the pH. That would be changing because we're adding base to acid. Remember, base now have a higher pH, acids have low pH. So when we add the base to the acid now, there will be a change in the pH. Everybody understand that?
Yes, sir.
So,
Yeah. So
Yeah.
it's just like all right, you have some boys growing up in your house, like you, Tara, you have a son there. As he grew up and you get sons, look at that, very blessed
and the nephew.
and a nephew. See that you're blessed, so you can relate to this then. When them grow up, all right, so you have them in the house there, right? And then now slowly but surely, they are being exposed now to a little bit of the girls, right? And so each time more girl add to them eyes and to them brain and them psyche, what's going to happen to them behavior? Would it be the same as them nice now and cuddly?
Change.
It's going to change. The same thing here happen here. Same thing happen here. So acid minding its own business, base minding its own business, but then slowly add the base to the acid and say that acid will respond to the base. All right. And how we measure it to the change in the pH. So it's the same thing. All right. Any questions here?
No, sir.
All right. So we just get the variables out of this. This is why important we talk through the labs them. You ask your questions and then and you read, go over your notes after class and try and understand what is being said here. And this class, as it is now, is being recorded on YouTube, so you can actually see it and play it back. But all right, so we have 3 variables here. This is actually 3 marks going towards the lab here. And of course, the diagram that you would draw is just something like showing how you carry out the titration. So this part will be easy. We still might need more materials here. If we're going to use the pH approach, because this lab here, you want to test, you can use 2 things to test the change in pH. So let me just go back to the variables in the lab here. pH of the solution is 1, or we could say color change of indicator. So of indicator. No, I have not thought about indicators as yet. But that's okay. It does the same thing as changing pH. So it's like you use an indicator when, well, in a case where you don't have a pH meter. All right, a pH meter. Let me show you what a pH meter look like. A pH meter. pH meter, and there is actually 2 types. You have pH paper, which is color change just the same, but then you have the pH meter now, which is digital. The one we prefer to use, but you have some simple ones and we have some really advanced ones. I think around my house here I have both of them, so let me just show you what one looks like here. All right, this is it, guys. A simple pH scale. Everybody seeing this? This is a pH meter. All right. And so you just read the number here. And these ones are, I don't like them. I've used them and I don't like them. They have more sophisticated ones. Let me see something. More sophisticated ones here, like this one. All right. So again, this is the probe part. This part must usually keep this part in in a neutral solution to make sure that it stay neutral. But then this stick here, just put it in whatever solution and it gives you a pH reading digitally on a LED screen here. And that's how you use it. So that's how it work. So it work, guys. Let me see something there. All right, now let me see something there. I see. All right, pH. All right, so let's go back to this then. If you're not using this though, if you're not using the pH meter though, the alternative is to use let me just write pH. The alternative is to actually use an indicator. Now, there are advantages to using the indicator sometimes. Because the indicator, first of all, it's well, let's just say it gives you a more visible thing. So with the pH, say with the pH meter now, guys, what you find happening is that sometimes the pH can change so fast, you might miss it. With the indicator, I'd say you have a little bit more time and a little bit more room for error there. As I've used the pH meter to do a lab once, and it didn't work well. Actually, it was working so well when I was adding a small amount of acid to a base, and then I just like went one little drop over, and the pH just shoot up. So you couldn't really get the control you want. But when with the with using the indicator now, the indicator color now, usually you get some. The indicator is like in an acid, it don't have any color, but in a base, the color change to like a bright red or something. So when you slowly add it now, what happens is that the color comes before and goes away, come and go until it start get a permanent color change. So the only thing left for me to do to emphasize that is like the showing you a video of what that is. But all right, let's see now. Let me see something. Because that will help you to understand here. All right, just in a minute, I will all right, let me just change the screen quickly, guys, and show you this. All right, and all right, let me just change it. So new share, guys, and I'm gonna share the sound as well, share the clip and screen 3. All right, everybody seeing this?
Yes, sir.
A two-part video series on titration. The purpose of a titration is to quantitatively determine the concentration of an unknown solution, commonly called the titrand or analyte, by adding a volume of a chemical with a known concentration called the titrant. To mark the endpoint of a titration, an indicator is added to the analyte.
All right, stick up in there. Just remember them say indicator added to the analyte. All right, analyte away we put under the burette in the flask. All right.
Let's review some of the equipment that's needed for a titration. Carolina's complete burette assembly contains the basic equipment to get you started, including a burette.
All right, next thing to guys, the burette. You see how the Americans them spell burette. British them spell it with 2 T.
2 R and 2 T and 1 E.
Yeah, so
A lot of extras.
yeah, Americans tend to cut spelling.
Ring stand, and a burette clamp. A burette is a long,
see all of them things
narrow,
they add now, you go add that to your list of apparatus. I go add it still while you go through. But
graduated tube used to add titrant. It has a stopcock to regulate the flow of liquid. Notice that the markings on the burette go from lowest at the top to highest at the bottom. The ring stand and burette clamp are used to mount and secure your burette. Other materials you will also need include a small funnel to help you fill the burette, a 125 milliliter Erlenmeyer flask, which works best for titrations. The shape of the flask allows for more vigorous swirling than a beaker or other glassware and minimizes spill hazards. A volumetric pipette and pipette bulb to transfer a known volume of analyte to the flask.
all right, I'm sure. You see when I'm just about the flask where minimize spillage. That's going to be a precaution. All right. And see the next precaution here. Wash bottle with deionized water. So you see all of them things there, I'll drop that in a lot because those are marks those are things you're going to get marks for. So write that in. Precaution. Oh, when we did write the precaution already. We never write the source of error. All right, so sources of error. All right, well, source of error. Let's play
A
out.
wash bottle filled with deionized water, a beaker or flask of titrant and of analyte, indicator selected for your reaction, a reading card to help read the meniscus, and a sheet of white paper to help visualize the endpoint. To prepare your burette for the titration, it is good laboratory practice to rinse your burette thoroughly with deionized water, then with a small amount of titrant. After each rinse, open the stopcock to allow the liquid to drain out the bottom. If there is a lot of liquid clinging to the walls of the burette, then thoroughly clean your burette and repeat the rinse process. The accuracy of this technique is dependent on the titrant flowing into the flask and not sticking to the walls of the burette. Mount the burette in the clamp, making sure it is positioned vertically, and there is enough room to position your flask underneath the tip. Check to see that the stopcock is in the closed position. Insert the funnel into the top of the burette and fill with titrant almost to the top. Filling exactly to the 0 mark is not necessary, but you do need sufficient titrant to complete the reaction. Check the column for air bubbles and gently tap to free them from the side walls. Remove the funnel. Place the Erlenmeyer flask under the tip and open the stopcock to allow a few milliliters of titrant to flow through, releasing any trapped air. Rinse the tip of the burette with water. Empty the liquid into a waste container and thoroughly rinse the flask. It is not necessary to dry the flask. Record your starting volume. It is important to accurately read the volume on the burette. First, note that the liquid forms a concave meniscus because the water pulls itself up the side walls of the glass. You should read the volume from the bottom of the meniscus at eye level.
All right, you see that, guys? That's a precaution as well. So you can add that. You only need like 2 precaution for this lab, and you already have 2. But if you want to write those, you need to. You can write them down. Doesn't matter. And the next thing with the burette now, guys, is that when you're measuring the volume, it's like you read it twice. You read the initial volume. That's where your volume when you start with, and that's your, as him say already, you read at the bottom of the meniscus, right? So that's so even though the curve would have come up to this number up here, so we're going to read this number, we're going to read the number down here. So, but you understand that?
Yes, sir.
Yeah, we read below the curve of the liquid. All right, at eye level. And as you say, him use a paper here to sort of block out the light so you can focus the reading. All right.
The glass. You should read the volume from the bottom of the meniscus at eye level. Secondly, it is important to read your volume to the correct number of significant figures.
All right, stick up in there. You see, it's him use milliliters, guys. Just highlight milliliters is the same thing as centimeter cube. Everybody get that?
Yes, sir.
Yes, sir.
All right. Wait, all right.
This burette indicates volume to the nearest 0.1 milliliters. With any graduated glassware, record the volume to 1 additional decimal place beyond the smallest graduation. In this case, record the volume to the nearest 100th of a milliliter, estimating the final place. Use the volumetric pipette to transfer the analyte to the flask. Add
All
a
right,
few
stick up in there. The pipette to the flask. All right, you see all of them steps, you know, you can watch this video. The link for this video is in the lab sheet, so you can go on the lab sheet and click on it, and it will carry you to this video that I'm showing you. All right, so once you have the steps, you can summarize the steps you see in here. Then you'll have the method for the at least you'll have most of the method for the lab. All right.
2 drops of indicator to the flask and swirl. Place the flask under the tip of the burette. Record this volume. Placing a piece of white paper under the Erlenmeyer flask may make it easier to detect the color change. Operating the burette requires 2 hands. One hand turns the stopcock, while the other hand swirls the flask. Practice turning the stopcock a few times to familiarize yourself with how quickly the flow starts and stops. It is common laboratory practice that the first titration is an estimate. Open up the stopcock and allow the titrant to enter the flask quickly.
You realize that the color in there coming and going?
Continuously swirl the flask.
It's not stained.
As the volume of titrant in the flask increases, the color of the indicator appears, then disappears as you swirl. When the analyte becomes a colored solution, close the stopcock.
Yeah.
Record the final volume of the burette. Subtract the initial volume from this final volume to get the estimated volume of titrant needed for this titration. Knowing the volume that is a little past the endpoint, subtract 5 milliliters from that number to get the amount of titrant that can be safely added before a slower addition is required.
All right, stick up in there. You see, guys, the first titration you run in an experiment like this is a rough one. It's considered a rough one. There's the reason you just want to get a rough idea of how much base you need to neutralize the acid, all right, or to reach the endpoint. All right, so in a titration you do a rough. In fact, in the data to be collected part of the lab, that part now you're gonna show me a table showing me what you're gonna do here. Is like you're going to have the same table we have. Let me just go back to where I did show that. You see, like when I have here for the trial one, you're going to have this in your data to be collected. So you're gonna show me like like so you're gonna say no. Trial one. Are in the Caribbean here we say rough titration, and then of course we have one. We normally do 3 titrations though, 2 to 3, because accuracy is important for this. You run the titration at least 3 times, even some cases 4. All right, so you can get an accurate reading. When you get 2 readings from 2 different trials that are close to each other, those are the ones you're going to use for your measurements. So look at this, for example. You remember, so you get the initial volume first. That's it. When you pour the liquid in the burette and you read it, that's the initial volume. After you add it to the substance now, and you're adding it until like the color change, then they want to take your final reading at that point. All right. When you write down those 2 readings now, you're going to subtract the first reading from the second reading to get the volume that you actually added. All right, so that is how you're going to do it. So this one now, you're going to have your final, you have your initial, and then you have your volume added. I'm going to switch back the screen shortly to see what that will look like in a table form. But you'll get marks for that in the lab. All right, so all right, any questions here, guys?
No, sir.
All right. So now let's see what happens here. Okay.
Added before a slower addition is required. As the estimate titration shows, a dark colored solution indicates an excess of titrant has been added.
Stick up in there. You see the next thing with the indicator now, guys, if the color too sharp or too dark, as we say, he was saying that you'd add too much of the substance there. So you want it to be just, when it done, the color change shouldn't be so drastic. It should be like a faint pink. This looks more darker pink, but you want it more of a light pink.
The desired endpoint is a pale, faintly colored analyte.
Yeah.
To reduce the risk of passing the endpoint, slow down the addition of titrant when flashes of color begin to appear in the analyte. Adjust the stopcock to slow the flow of titrant to a dropwise rate. Continue to swirl the flask with one hand and keep the other hand ready to close the stopcock. When you notice the indicator taking longer to fade, close the stopcock. Rinse the tip of the burette with deionized water and swirl the flask. Record the final volume on the burette. If the analyte remains faintly colored, then you have reached the endpoint. If the analyte is still colorless, then repeat these steps. Add a drop, rinse, swirl, and record until a faint color persists. Typically, titrations are performed in triplicate. Use the average volume of the titrant required to reach the endpoint for any calculations. You now know how to properly perform a titration. Be sure to check out the second video in this series. In that video, we will go over the proper procedure for determining the concentration of an unknown acid solution using a base of known concentration.
All right, stick up in there. All right, guys. So did you learn from this video?
Yeah.
All right, good. So, all right. So yeah, that's where I'm gonna actually stop it for this evening, because I want you guys to have the basic idea here. So and the second video that he's referring to, if we can find it, so that video is would tell you more now of what you're going to do for this lab. So just to point out to you guys that well, you draw a diagram. What I recommend is that you get the diagram, and of course go back through or find videos that where a person is doing a titration. Look at the steps that they give you, or you could watch this video and you look at the steps and you can use that. But one of the first things I would want you to put in a method, though, let your first method be something related to the diagram that you have, which I recommend that you set up your draw, or you use a picture of a titration setup. So I showed you that before. It's in one of these slides here. Thing is this one. So let's say, for example, I could just copy this picture here and go back to that. And the diagram looks something like that. As a matter of fact, let me just paste it here. And I'm going to zoom out and show you can really get creative here. And just cut out that. So, and that's the diagram. There's a diagram here fit nicely. And if you just small it up, but then can zoom in back and get the all right, so that's what it's going to look like. All right, so I made it. Yeah, I mean, of course, yours going to be a lot bigger though, but certainly this could work for a diagram. And then as well as, yeah, so this is what it's going to look like. So your method now would match up with what is shown in the diagram. All right, guys, so that would take care of the plan and design lab here, at least most of it. And that's it. So so we're gonna stop here, guys. All right, anybody have any questions?
No, sir.
So,
All right, good. So as I say, I hope you learn something here and that you can apply it to the lab. If you have any questions, I emphasize ask in the group as much as possible. Once it's something that we do in class that can benefit everybody, ask a question in the group. All right. I've been getting some labs from some person. I think I got yours. Was it Leandra? You sent me yours. All right. Let me see something. Leandra, or was it you that sent me? No. Somebody sent me some lab. Like they were gone. All right. But guys, I would say, just ask the question them as much as possible in the group so we can address everybody, or at least persons listening or seeing can learn from it as well. All right, guys. So thanks for coming on today, and I'll see you guys on Wednesday. All right.
All right,
yes,
sir.
sir.
Okay, sir. Same to you.
All right. Enjoy the rest of the evening. All right.